All right, hey kids. So today what we're going to do is we're going to do solving systems of equations by graphing. Now, some of you are going to be like, oh my gosh, we've done this over the past like 6 years of math. That is true, but today what we're going to do is we're going to incorporate geometry into this. So what I mean by that is we're going to use quadratics when we do our system. So today we're going to solve a system by graphing, and we're going to do it with the use of our calculator a little bit and by hand. We should be able to do these by hand, but if you need to use your calculator, you totally can. So here you go. Clearly you don't have a sheet of paper, but if you could take out your textbook or something that has a graph, I want you to try to do this. I want you to try these. I want you to pause, try these three, and then play it up and see what I did and see if we got the same thing or something similar, okay? All right, so here we go. So this draw systems of equations that satisfy the following. So here we go. Two linear equations with a solution at 2, 6. So, or sorry, 6, 2. If you were going to do this, draw a system with two linear solutions at 6, 2, you actually start at 6, 2 because you know where they're going to intersect. So you go right 6, up 2. So that will be our solution. So you just draw two linear solutions. Now, it didn't say one's positive, one's negative, or both positive, or whatever. So I just draw them like that. That is two linear systems with a solution at 6, 2. Now the second one is two quadratic equations with one solution at -5, 4. So again, we're going to start at -5, 4. All right, so left 5, up 4. So here it is. And then if you're going to draw two quadratics, now the best way to do this, two quadratics with one solution, all right, is to have that be the vertex of both of them. So we're going to have both of these quadratics have a vertex at -5, 4. And the reason you do that is because if you were to try to put them, like have them intersect with their sides, like do something like this here and this, that could work, all right, but eventually this one could catch up with this one. So there could be another solution. So we wanted one. So the best way to do that is to put the vertices at that point. All right, so not the yellow, but the pink that I did originally. Now lastly, it's one linear and one quadratic. Now this is what we're going to be dealing with today, is we're going to have one linear, one quadratic. But this has two solutions. So we got a solution at 2, 2, and then we have a solution at 5, 4, right? 5, up, 4. So what I would do to deal with this problem is I'm actually going to put my line through this, all right, because my line has to have these two as a solution, and then I'm going to make my quadratic do something like this. You see that? Now again, it's not super accurate, but it's just trying to get you the idea. Oh, and your lines need to have arrows. All right, it's just trying to get you to see the idea of like linear and quadratics intersecting, where they can intersect, how they can intersect, and just kind of getting you to start thinking about things like that. Because this right here, this first one, two linear equations with a solution at 6, 2, you've been doing that one forever. These next two are the new ones that are trying to get you to think about all these new things that we've learned this year. So the sub should have passed out this sheet right here, okay? And what I like about this sheet is that you're going to practice graphing actual linear and quadratic. So pause the video again, and I want you to do these top two. All right, I want you to do these top two on your own, and then if you get this the same as me. All right, here we go. So the first one, linear. So when you do this, y equals mx plus b, we're going to begin at our b, so -8. So we're going to begin down 8, and then our slope of -3 is really -3 over 1, which means down 3, right 1. So to get the rest of our points, we go down 3, right 1 from our b, which is down here, which I don't have. But now we go up 3, left 1, up 3, left 1, up 3, left 1, up 3, left 1, up 3, left. I notice mine's off because I'm on my computer, but you want to go as far as you can with your points. And there's your linear linear graph. Now, the second one, this is quadratic. Now, this is what you did your test on, all right? Identifying, vertices, x-intercepts, all that stuff. So you should be able to do this. Now, the first thing that I would do is I would find my vertex. All right, so your vertex is, you start off with x, so x equals negative b, so it's negative 4 over 2a, which is 2 times 2. Sorry. So you should get negative 4 over 2 times 2 is 4. So negative 4 over 4 is negative 1. And now you're going to substitute negative 1 back into this system. So our vertex, all right, is going to be negative 1 comma something. All right, so when you put in the negative 1 in here, negative 1 squared is 1, 1 times 2 is 2, and then 4 times negative 1 is negative 4, plus, or sorry, 4, and then minus 6. So 2 minus 4 is negative 2, minus 6 is negative 8. So our vertex is negative 1, negative 8, which is down here. Now, another thing that we know is that our vertex has our axis of symmetry running through it. So our axis of symmetry goes up and down here, and that's going to help us out with the rest of our graph. All right, because it is in standard form, our y-intercept is negative 6. And then, because, I don't know why that's highlighted, but whatever. All right, because it's negative 6, and here's our y-intercept, and we have our axis of symmetry is at negative 1, I can count over one more, and there is my my symmetrical point for my y-intercept. So I kind of have an idea of what my graph's going to look like. It's going to do something like this. Now the last thing that I need are my x-intercepts. Now my x-intercepts can be found by, well, in this form, because it is in standard form, I'm going to erase all this, I'm going to factor. All right? Now, I realize right away that there's 2, 4, 6. These are all divisible by 2. So I can factor out a 2 first. So I get x squared plus 2x minus 3. Then I say, all right, well, can I break this down into 2 binomials? Okay, don't know. I really hate writing on my computer. You kids all know that. Anyway, so here we go. What two numbers multiply to negative 3 but add to negative 2? This is positive 3 and minus 1. So your x-intercepts are negative 3 and positive 1. So at 1 and negative 3, you have x-intercepts, and there is a very, very accurate quadratic graph. This and this are what you're going to have to be doing today with accuracy so that you can figure out what your intercepts are. So here we go. Let's fill out some notes. All right. So a system of equations is when you have 2 or more equations. Now today we're just going to be working with 2, but sometimes you can have 3, 4, 5, 6, and that's when the fun happens. Now the solution to a system of equation is always the point of intersection. All right, so it's where they cross, intersection, the point of intersection. So let's review what system of linear equations looks like. So to have no solutions, that means your lines don't touch, which means your lines are parallel. All right, one solution is like what we did on our example right there. All right, here is your one solution. And infinitely many, now this is a fun one. All right, this is when you have one line here, and then you have the exact same line literally graphed right on top of it. Infinitely many, it's the same line. All right, so that's just a little review. Hopefully many of you remember that. So now what we're going to do is we're going to have some fun doing big boy, big girl systems of equations. So it says graph the system of equation below and determine the real solutions if any exist. So what we're going to do, for me, I'm always going to start by graphing the linear. The linear is always the easiest. All right, so I'm going to start with my b, which is negative 2. So I'm going to start down 2, and then my slope is 2 over 1, which means up 2, right 1. So I want to make sure I graph every single point of this linear graph. Up 2, right 1, and then go down 2, left 1, down 2, left 1. Because you have no idea where the solution is. Oops, don't know why that happened. All right, only one line. There we go. So now, all right, the second is the quadratic. Now the quadratic, it's up to you how you want to figure it out, what you want to do. But for me, all right, what I'm going to do is I'm going to first find my vertex. And my vertex is negative b, so my x value is negative b, so negative 2 over 2a, 2 times 1. So negative 2 over 2 times 1 is 2, so it's negative 1. So my vertex is negative 1 comma something. Oh, perfect. Gotta love how my computer's doing this. So hopefully your algebra and your handwriting is a lot better than mine, because right now I'm seconds away from throwing my pen through the screen. So -1 comma something. So to find your b value, you're going to put your negative, or your y value, you can put your -1 back in, and you're going to simplify. So -1 squared is 1, and then 2 times -1 is -2, and then -2. So 1 minus 2 minus 2 is -3. So our y-intercept, or our vertex, is -1, -3, which is right about here. And if you look at my graph, I graphed that poorly because it's on my computer. Those are not touching yet. All right, that is not your solution. God, this is an amazing lesson for me not to be here on. All right, I'm going to erase that. All right, so here is your -1, -3, and then your line was down 2/1. So really, we just went right underneath it. So we haven't touched it yet. So now what we have to do is we have to figure out some other things. So if you look, the next thing we want to do is our y-intercept. Our y-intercept is -2. Holy cow, that right there is a solution. So one of our solutions right now is 0, -2, our y-intercept. Sorry, that's 0, -2. So because we have an axis of symmetry here going through our vertex, all right, we have another point over here. So I know my graph's going to do something over here. I don't have a solution over here. Again, this is trying to find your real solutions. And because I found this point, it's going to come up, and we are not going to have another point on this graph. So this is our only solution, 0, -2. That's our only real solution. Because once you hit, it's not like it's going to dip underneath here and go and touch. It's not going to do that. All right. This is your only solution. So this is really what we're doing today. This is really all that we're doing. So flip the page. All right. So we're going to try these two now. All right. So example 2. So if you look here, see how it's 3x? This is really +0. So your y-intercept is 0, and our slope is up 3/1, up 3/1, up 3/1, and down 3, left 1, down 3, left 1, down 3, left 1. Now again, as I've said in all my videos, if you are like, good God, this guy's going super fast, you can always pause and replay it. All right. So now that's your linear. So now my quadratic here. All right. What I'm going to do is I'm first going to find my vertex, so -b. So I'm going to find my x value. So my x value is negative, I don't know why that keeps doing that, -4/2 times 1. So -4/2 times 1 is -2. So your vertex, all right, is -2 comma something. So when we substitute it back into our equation, -2 squared is 4. -2 times 4 is -8 minus 2. So net 4 minus 8 is -4, minus 2 is -6. So our vertex is -2 and -6. And if you look here, holy cow, my vertex is actually one of the points that were on here. And I know that it was because I've done this before, but it's right there. Now, take a look. That is one of my solutions. Another solution we're going to get here, take a look, is going to come when we do our y-intercept. We're going to realize that our y-intercept here is 0, -2. So our graph is going to come out here. We're going to touch one more time somewhere over here. So we're going to have to try to figure out what that point is. All right. And again, I apologize for all these colors that keep popping up. These are these amazing computers that our school got, so that's awesome. So anyway, so we're going to count from this y-intercept to get another point. 1, 2 to your axis of symmetry, 2 over. All right. So we're not going to have another point of intersection over here. We're going to have another point of intersection somewhere over here. So, all right, what we're going to need to do now, all right, what we're going to need to do is, clearly it's not going to be our x-intercept, but it could be this point right here. It could be this. Now, the reason I'm saying that it could be that is because I know it's that. Because It clearly can't be 0, 0, 0 because we're already at 0, -2, but it could be this. So what we're going to do is we're going to put x as 1, x equals 1 into our equation right here and see if we get 3, because that's what that coordinate is. That's right here that I'm circling. So if we do this, 1 squared is 1. So we're going to get 1. 4 times 1 is 4. And then minus 2. 1 plus 4 is 5, minus 2 is 3. Holy cow, that is our other point of intersection right there. So we actually had 2 points of intersection here. We had 2 of them. We had this point and this point. So our solutions to this problem are 0, -2, and 1, 3. These are your solutions. Solutions. All right. So what I want you to do is I want you to try number 3 on your own. I want you to see if you get the same answer as me. Pause and then play it out. All right, number 3. So we're going to start down 10, and we have a slope of -4. So I mean down 4 over 1, so the point would be somewhere over here. So we're going to do reverse slope. Up 4, left 1, up 4, left 1, up 4, left 1, up 4, left 1, and then right there. I don't know why this screen's not working. All right, so there's our line. Now our quadratic right here. All right, we're going to first find our vertex, so our x value is -b, so it's going to be 4 over 2a, 2 times 1. So our b value is going to be 2. All right, I don't know why I keep saying b value, but your x value of your vertex is going to be 2. So our vertex is going to be 2 comma something. So we substituted in 2 squared is 4. 4 times -4 times 2 is -8 minus 6. So 4 minus 8 is -4. -4 minus 6 is -10. So our vertex is 2, -10. Now, all right. Now we're gonna keep chugging along here. So we got our y-intercept is -6. So we're gonna have a symmetrical point, 1, 2, 1, 2 over on this side. So our graph is gonna do something like this over on the right, but on the left we're like, oh man, I'm not sure exactly what's going to happen. And again, I apologize for this pink thing. I don't know why it's pink and this is happening. But anyway, over here, so what we're going to want to do, the only thing that could potentially intersect over here is an x-intercept. So we're going to want to find our x-intercept. And that is by trying to factor this out. So we're going to say, hey, what 2 numbers multiply to 6 but add to 4? All right, what 2 numbers multiply to 6 but add to 4? Well, the only numbers that multiply to 6 and add to 4 are 1 and 6 and 2 and 3, and neither of those will give you 4. So what you're going to actually have to do is a quadratic formula to figure out what these points are. All right, so that is something that can happen. Now, all right, when you do that, all right, so x equals the opposite of b, so 4 plus or minus the square root b squared, so -4 squared minus 4 times 1 times -6 all over 2a, which is 2 times 1. All right, I'm going to do this in my calculator. You should get 2 answers. You should get, all right, you should get 4 plus or minus some number over 2. So when you do that in your calculator, where am I at? So you should get the square root of 40. Now here's the deal. Because we want an answer, we're going to have to do this. So 4 plus, now you're going to need to know what the square root of 40 is. The square root of 40 is 6.32. So this really should be 4 plus or minus 6.32 over 2. So I don't care about the positive one. I know 4 plus 6.32 is 10. And then 10 divided by 2 is 5. So your x-intercept would be somewhere over here. I know I kind of approximated. But we want the negative one because we want to see where it's going to hit. So we go 4 minus 6.32. So 4 minus 6.32 is -2.32. divided by -1 is -1.6. So if you look, our x-intercept is going to be somewhere right around here. We are not going to hit this line. We are not going to hit it. So that is what's going to happen. When doing these problems, I'm not going to try to kill you, but I am going to have you think. It will hit in one of a couple places. It's going to hit on the vertex. It's going to hit on the y-intercept. It's going to hit on an x-axis or x-intercept. Or it may potentially, like if it already hit once, it may come back and hit the line. So you're going to test another point that was on your line. If it doesn't hit your vertex, y-intercept, or your x-axis, or your x-intercept, all right, so your vertex, y-intercept, x-intercept, it's not going to touch at all. So this is no solution because it doesn't touch at all. There's no solution. It doesn't touch. There's this space right here that it never hit. All right, here's our last ones of the day. So this is solving a system that appears to be represented by the circle below. So I have a circle that's right here. All right, all we're going to do is we're going to graph these lines and see how many times they touch. Now this is a quadratic. Now the line's easy. The line, you start by graphing 9, and then our slope is 3/2, so that means up 3/2, or down 3, left 2, down 3, left 2. Hey, that touched right there. Down 3, left 2, down 3, left 2. So if you notice, our line has a solution right here. This is your one solution that hits your circle going around, and the solution is -4, -4, 3. Now, that's not the hard one. The tough one is here with the quadratic, and you're like, oh my gosh, there's a fraction, this is crazy, good golly. Don't worry, all right? So to find your vertex, all right, you're going to go -b/2a. Well, the cool thing is there is no b, so -0 over anything is 0. So your vertex is going to be 0, comma, some number. So you're going to put 0 in for x. 0 squared is 0. 0 times a half is 0. 0 minus 5 is -5. So your vertex is going to be -5. Oh my gosh, that's a point. That's one solution right there. Now, let's find our x-intercepts. Because if you notice, this is in standard form. 0, -5 is your y-intercept also. So your y-intercept and your x-intercept, your y-intercept and your vertex are the exact same. All we have to do now is find our x-intercept. And because it's written like this, where there's only one variable, I'm going to set this equal to 0, and I'm going to solve. I'm going to add 5 on both sides. I'm going to solve for my x-intercepts right now. So 0 plus 5 is 5 equals 1/2 x squared. I'm going to divide by half or multiply by 2 to get rid of this. So you're going to get x squared equals 10. And then we're going to lastly take our square root, and we want a number because we're trying to graph this. The square root of 10 is 3.16, so it's plus or minus 3.16. So we're going to graph 3.16 is just after 3, -3.16 is just after negative there. So if you look, it's already starting to come up like this. Now, all right, where do we get the rest? Because clearly it's going to hit somewhere over here. Clearly it's going to hit. So what we're going to do is we're going to think, okay, all right, possibly it could hit at 4. Possibly it could hit right up here at 4, like where x is 4. So what we're going to do is we're going to substitute and just try to see if we could do process of elimination to see if it will touch there. So by putting 4 into this problem, all right, by putting 4 into this problem, we're going to get coordinates here. All right, so if we were to put 4 here, 4 squared is 16. Half of 16 is 8. 8 minus 5 is 3. So when we put 4 in, you get 3 back from your equation, which means that this is a solution. And then it's the same thing if you put in -4. You'd get the same thing. So you actually have 3 solutions. You have 1, 2, 3 solutions. And this little trick of me like putting 4 in, is because I knew that these were my x-intercepts. So I knew if it was going to touch, and it would either be 4 or 5. So I test an x value of 4 to see where it would hit on a y value. And it hit at 4, 3, which is on our circle. So our solutions, all right, are 4, 3, -4, 3, and 0, -5. Those are our solutions. And that's an S, and this should be a -5. Those 3 points. So with a quadratic, you can have more than one solution, which is different than when you graph two lines a long time, in the past 7 years, right? So it's important that you use the skills that we're doing now to help you determine what exactly are your solutions. So tonight, your homework, all right, we're not doing that. Your homework is going to be page 207, 209. You're doing problems 1 through 4, all right, 1 through 4. And then you're also doing 1 through 9, or 9 and 10. And then the sub has a worksheet that has 4 problems on it. So you got 4 problems here, 2 here, and 4 here, giving you a grand total of 10 problems, okay? So, all right, just make sure you're doing these problems, and we'll check them out tomorrow in class. Thank you. Have a great day.